Hello everybody, welcome to this second video on writing ionic equations. Now in the first video, we only addressed chemical equations or chemical reactions that involved reactants that were all in the aqueous state. In this video, we will be addressing chemical reactions with reactants that are present in states other than the aqueous state. Right, so let's begin. Now, for our first example, let's take a look at an acid-metal reaction. Now, in this case, we are reacting zinc with hydrochloric acid, right, and for it to form zinc chloride solution and hydrogen gas. Now, for the ionic equation, right, let's take a look at how it should be written. Firstly, let's look at zinc. Zinc is a solid, so therefore it will remain as a solid in the ionic equation. Hydrochloric acid is an aqueous compound. Therefore, we will split it up into its ions. Alright, so we have 2H plus AQ and 2Cl minus AQ. Next, we look at the products. For the products, we have zinc chloride solution. As it is an aqueous compound, it will be split up into its ions. Zn2 plus AQ and 2Cl minus ions. The other product, hydrogen, is a gas. Therefore, it will remain as it is. So let's now take a look at how we can work out the net ionic equation. So first, let's take a look at which are the spectator ions. Zinc is a solid in the reactants, shown in the purple region. In the products, zinc has formed an ion. Therefore, they are not the same, they cannot be cancelled out. H plus appears in the reactants, but not in the products. In the products, it has formed H2, therefore it is not a spectator either. Lastly, we look at the chloride ions. Chloride ions appear in the reactants. They also appear in the products. Therefore, the chloride ion in this reaction is a spectator ion. It can be cancelled out. And therefore, the net ionic equation is zinc solid reacting with 2H plus ions to give you zinc ions plus hydrogen gas. And this is the net ionic equation for the reaction between zinc and hydrochloric acid. Now let's consider a slightly more complicated example. Let's look at the reaction between calcium carbonate and hydrochloric acid. Now the overall equation for this reaction is of course calcium carbonate reacting with hydrochloric acid to give you calcium chloride, aqueous, carbon dioxide gas, and liquid water. I have also shown here the total ionic equation if we were to follow the rules that we have been using so far and split up only the aqueous compounds in the reactants and products. And this is of course the total ionic equation that we would get. But does this look a little funny to you? The total ionic equation here, the only spectator ions that we will cancel out are the chloride ions, because only the chloride ions appear as they are, alright, in the reactants and the products, and therefore they will be struck out. And this is the net ionic equation. But does this look a little funny to you? Here, alright, in the net ionic equation shown here, the carbonate is actually turned into carbon dioxide. So actually this reacts. The carbonate actually reacts. Therefore, it cannot be left alone, and we should split up the calcium carbonate as well. Therefore, the total ionic equation, rather than leaving it like that, what we should do is that we should also split this up. Now, let's take a look at what we can cancel out. Let's look at calcium. Although calcium appears in the solid state in the reactants on the purple side, and whereas on the green side, or at the product side, it is in aqueous form, we see that calcium remains as calcium. There is no change. Therefore, we can see it also as a spectator ion and cancel it out. Over here, the carbonate on the purple reactant side is converted into carbon dioxide on the green product side. Therefore, it is not a spectator. Here for H+, it appears in the reactant side but not in the product side. Therefore, it is also not a spectator. Lastly, we see that for the chloride, it appears in the purple reactant side. It also appears in the green product side. And therefore, we can consider it as a spectator ion and cancel it out. Therefore, the net ionic equation should be the carbonate reacting with acid, right, the H+ ions, to give you carbon dioxide gas and water. And this, ladies and gentlemen, is the net ionic equation for an acid-carbonate reaction. I stress again, when a solid is reacting, we will have to take into account its individual ions when constructing an ionic equation, even though it is in the solid state. We can do so by comparing the reactants and the products to see if the solid compound has changed in any way. If it has, it most probably has reacted and therefore will need to be factored into the ionic equation as shown here in the acid-carbonate reaction. So this concludes our second video on writing ionic equations. I hope this video has been useful in helping you write an ionic equation that involves reactants in states other than the aqueous state.